Today I'm joined by Professor Xavier Golay, the CEO of the wonderfully named Gold Standard Phantoms, a business he's been involved in since 2014. Xavier also is current honorary professor at the University College of London, having been a professor of magnetic resonance imaging, neurophysics and translational neuroscience at UCL from 2008. With a master's and a PhD in physics, specialising in MRI, it's probably fair to say he's had an interest in this area all of his working life. Having now plunged into the world of commerce on a full-time basis, Xavier brings a fresh view to the challenges faced by young life science companies. So, good afternoon, Xavier.
Good afternoon, Ewan. Thank you very much for having me here. It's a real pleasure to have this chat. Yes, and thank you for the very nice introduction as well.
Tell me a bit about your background and your upbringing. What was that like? Where was it and what was it like?
So I am Swiss. I was born in a small village, actually. Very much very Swiss, as half of my family is involved in watchmaking. So I went to school at a time where very few people would stay in school in Switzerland past a 16-year-old, and I got to secondary school, or what we'll call A levels here, get into the EPFL, the Swiss Institute of Technology in Lausanne, where I did my studies in physics. During my studies, I had the chance to listen to a talk by the person who was going to become my first mentor, Professor Peter Bösiger from the Swiss Institute of Technology in Zurich, the ETH in Zurich. And it was amazing just at the time to look at images of the moving hearts acquired in vivo, and it sounded like an amazing technology. So I went on, got a fellowship to get a PhD in Zurich, and basically, as they say, the rest is history. I stayed in the field for all my life.
What was it that kind of triggered your interest in life sciences?
I started my physics studies in 1989. Okay. Now, this is before the fall of the Iron Curtain, and if you're going to become a physicist in these times, you had to take a stand as to whether or not what you're going to work on is likely to end up being making weapons or something like that. So, actually, I had two major interests in studying physics. One was biomedical engineering, biomedical sciences in general, and the other was energy, both fusion energy as well as generally energetic calculations of buildings and how can you actually improve energy efficiency, these kind of things. And that was, a very nascent field at the time. And I guess towards the end of my studies, I went on with what was really the stronger part of me, which was actually interest in medicine in general.
You were off in Johns Hopkins Hospital for a while as well, earlier in your career. Tell me a bit about that. How did that kind of shape your thinking and your values and so on?
Well, I probably the spell at Johns Hopkins was really by far the most formatting and the best time in my life to learn how to become a scientist. I had the pleasure to not only have one but several amazing mentors. Professor Peter Van Zyl was leading the lab there. Professor Peter Barker on spectroscopy, and other many different people I could work with. It was a time of learning beyond just the technique, because during my PhD, doing a PhD, you learn how to become a specialist in your domain, but you don't really learn how to become a scientist. And I think these were real formatting years in terms of actually shaping my thinking about how do you address a problem, how do you address an issue. If there is something, you need to do something about it, but often most of the issues that you have in real life are not simple.
How did you get interested in starting a business then, and the opportunities it offered you, as opposed to, continuing your career ever more in kind of academia?
So, how come I went to become an entrepreneur, as it were? It came out of frustration. Frustration in the early mid-teens of having worked by then for literally around 20 years on trying to improve MRI, and not seeing that many of the development that either myself or actually anyone in our field had done really reaching the clinical market and having an impact into the life of patients. And I knew from having worked for large companies that, well, the only way you can actually have an impact is if you can actually sell your solution directly, already packaged in a nice way to hospitals. And that was really the trigger to start a company. Just say, well, hang on a minute, this was something I would have liked originally when I was studying myself. We can try to make it and sell it to other people that might actually help them. And from them, I mean, this particular company, Gold Standard Phantoms, had multiple lives already in itself, moving into different directions.
What are the benefits of that mission then to the patient population?
The way MRI is acquired, the way MRI works is you can take different type of images. Not only it would be like having a camera and taking pictures in color or black and white to highlight different aspects. But in this case, you have a much larger set of possibilities. You can actually make your MRI signal sensitive to just the anatomy, but also sensitive to the measurement of, if you want, the density of a tissue. And for example, to check whether there is a cancer, this is a very good measurement. Now, that kind of measurements would be really important if it was perfectly quantitative. And here we're going to another field of physics, which is the field of metrology, the field of measurement, which is boring. And it's boring. And I have a prop here, which actually belonged to my grandfather, who is a watchmaker. And it's just, it enables you to actually measure something very precisely. You can measure a distance very precisely. On it just tells you, it's written very small, you won't see it. It just tells you it's only very precise if you measure it at 20 degrees.
Right, okay.
Right. So basically, the precision with what you can measure something has to do with the conditions around it. And that's generally the same. And making a measurement is having a measure, having a precision attached. See, are you precise 1 millimeter, 10th of millimeter, or 1 centimeter, or an inch? Any you choose your units, but it's the measurement is a number, a precision, and a unit. And so far, MRI does not have a precision, does not have an estimate of the precision. So it can not make real measurements. It makes it creates numbers.
Right.
And what we've developed is a solution now, which we're going to start using in clinical trial, where we actually, for the first time, can provide an estimate on a pixel by pixel basis of how precise that number you're getting is.
So, how does Gold standard phantoms resolve that problem? What are you producing to resolve that?
So what we are producing are actual reference devices that are called phantom. And these reference devices can either be measured on their own to check that the scanner works, or if you really want it to be used for calibration, you can have these devices embedded, for example, in the pad on which the patient lies, so that you're scanning it together with the patient, and then you have actually a reference within the image that you can compare things to. So it sounds very simple. It's a very simple solution, but as usual, the devil is always in the details, and it's actually relatively a very complex way of actually handling the problem. And for that, we are working with two metrological institutes: the National Institute of Standards in the US, NIST, and the National Physical Laboratory, NPL, here in the UK. And NIST provides us with a reference. So basically, we are making the juice that we put into these reference devices, and they give us a measurement with a precision at a certain temperature and etc. And it's really all very, very clear. So we can use that as the gold standard of the name.
Right? Yeah. Okay.
And then you can compare what you're measuring with your scanner to that and say, oh, I'm actually right bang on, or I'm 5% off, I'm 10% off. It's not the most glamorous of all the aspects of MRI, but it has enormous consequences.
What are the key technical challenges then in the work that you're doing?
You put the phantom, so the reference object, into a device that is actually not a human body. So you want to make sure that you make the scanner recognize that device as if it was a body, so that the image quality remains good. So that's the first challenge that you need to do. Another challenge that you have is the measurement of, in this case, the diffusion, which indicates how thick or dense a tissue is. These measurements are very much temperature dependent. So you need to have an embedded temperature measurement inside an MRI scanner. Now, an MRI scanner works inside a very big magnet, about 50,000 times higher than the Earth magnetic field. So it's very, very strong. There's all these things you can actually Google later on the internet, all the accident that happens if people come anywhere close to an MRI with any piece of metal. So here you need to make a measurement with a bit of electronics, and needs to be embedded into your device, and this needs to be compatible with an MRI. That means it needs to not be affected by the magnetic field and all the electronics that happens by the MRI, but also because the MRI is super sensitive on the electronics, your device should not make a noise, additional noise into the images.
What's been the biggest challenge since taking on the role of CEO at Gold Standard Phantoms?
Well, in the first place, when we started, like in 2014, we had no idea of what we were entering into, right? I had to have a very rapid crash course, one of our early investors, a good friend who coached me early on, was mentioning to me that I probably got the equivalent of the teaching of an MBA, but purely practical in a very short amount of time to get to the point where we could have a first investment round in 2017. But even there, we had some ideas and hope and not much understanding of how the market was really going to react. And we had big ideas, big plans, and as Mike Tyson was saying, everybody has a plan until they get punched in the teeth, right? So you need, just like on the ring, you need to be able to come back up from a punch in the teeth and just to go and fight
Keep
another
going.
bout. Yeah. So this is basically, it's been quite a bit of ups and downs, and finding our feet and finding the right way to go after the market and everything. It's been a really, really interesting journey, like a fantastic journey, actually. I'm very, very glad I took it.
What do you see as your biggest challenge in the medium term now?
Well, it's going to be actually being able to manage in a relatively niche place a company like that. So the cash flow of the company with the need for growth. This is basically the biggest challenge.
Yeah.
So for that, we are now fundraising, going after potential angels or venture capitalists. And we are, because there is a need to actually invest right now so that we can actually grow and get things to market in a fast enough way. I think we have a product market fit. We have had some wonderful comments from people working with large MRI manufacturers who would say that this is really needed. It's a clinical need, and they would love to have that to put on all their scanners. But for that to happen, we need to have even more people than what we have now. Otherwise, it's going to be, it's going to just take the time it takes, right? So it's having a lot of IP in there, and having the first go-to market is to be in a winning position for the company. So right now, one of my biggest challenge in medium term is this balance between growth. We're already, we've made nearly £500,000 last year. We've been growing 60% year on year in the last 4 years. So we're doing well. We're increasing year on year. There's no problem about that. But it's always this aspect of growing something from nothing. It's a very interesting process.
Have you had investment so far? And if you have, what's your relationship with your investors been like along this journey?
So we've been very fortunate that we didn't need a whole lot of investment over the years from angels or VCs, because we managed to get quite a large number of dilution-free money from the government.
Right.
So we got a large number of grants, and that enabled us to go a long way until we started being selling our devices. So we had one round of investment, like a pre-seed round with angels. And at that time, we were relatively, short of money, and it was really a need. We needed to get that money. And so we took money from angels who basically didn't do too much of a due diligence. They took us at our words, but we were trying our best to try to understand what the market was going to react for. And basically it led to, after the investment, to some relatively sometimes difficult conversation, because we had to admit that our understanding of the market was not as much as we had liked to.
Okay.
So that was one thing, and I'm very honest about it. But also, neither us, if you want, nor our investors were really knowledgeable about that particular subfield or market. and that can lead to some issues and some tensions. Yeah. So I think I would if I had the time, if I could go back in time, I would probably try to have more people on our board and more investors that would know more than me at the time about the market rather than less.
Finally then, if you had the opportunity, and maybe you've answered this a little bit, but an opportunity to go back on yourself, on your life's journey and give yourself some advice early on, what would it be?
Trust yourself more, probably. You can make it. You need to be more confident, and that's one thing. And another, which happened to me more and more, which happened a lot during my life, is life will throw you lemons, so you better learn very early on to make lemonade. I mean, it is a problem. You cannot really plan things 2-3 years in the future and hope that it's going to get there. I mean, I would never had hoped that I had to give up my position as a professor. It turned out that I had enough and I wanted to change and I wanted to do something. But I mean, yeah, I would just say have more confidence in yourself. And I think that's the one thing I would just tell my younger self. And that, in general,
doesn't it?
Yeah, things get better in the end.